Hey guys, welcome back to the Maths Club. We're continuing our series on logarithm and we're looking at simplification in logarithm. Although we've already touched on this in the previous video, but I thought to share some more examples that will shed light on the laws and the application that we talked about in the last video. So if you do not watch the video, you can check the description for the playlist on logarithm and you will see the video there. So in the last video, we talked about the three laws of logarithm, the law 1, the law 2, and then the special cases, right? So today we're just going to be building more with more concrete examples. So this question is saying, evaluate log square root of 35 base 10 plus log square root of 2 base 10 minus log square root of 7 base 10. First things first is that we know that we can be able to express square root as raised to the power of 1 over 2. Based on all we know on indices. So they're saying log 10 35 raised to the power of 1 over 2 plus log 10 2 raised to the power of 1 over 2 minus log base 10 7 raised to the power of 1 over 2. And based on the law of logarithm, we know that we can be able to bring this power down by saying half log 10 35 plus half log base 10 2 minus half log 7 base 10, right? And if you notice there is half present, that means I can factor out the half and say half log 35 base 10 plus log 2 base 10 minus log 7 base 10. Great. What else do we know about this? They all have the same base, right? Since they all have the same base, if it's addition that is joining them, we're going to do what? We're going to multiply. So let's do it in bits. So let's say half open bracket log 10. I'm going to multiply this because they have the same base. This is like saying 35 times 2 minus log 10 or log 7 base 10. So I can resolve this further and see this is half log 10 70 minus log 10 7. And if you look at our law 2, when we have something like this that have the same base and is minus, we can divide and say half log 10 70 divided by 7. This is like saying half log 10 70 divided by 7 is 10. And we know that when we have log 10 10, we know that this is going to give us what? It's going to give us what? So it's like saying half times 1, and this is what? Half. So at the end of the day, using the laws of logarithm, we're able to find what this value would actually give us. So you must be able to look at patterns and know what to be able to factor out and know what to be able to divide and all of that. So let's see if our answer is correct. Great. Now this next question is that we should simplify log 15 over 8 base 10 minus log or minus half log 25 over 81 base 10 plus log 400 divided by 81 base 10. So we know something. First things first, this is the only one that has the value before the log and they are all in the same base. So let me take this up and say log 10 15 over 8 minus log 10 25 over 81 raised to the power of what? 1 over 2. Great. Plus log 10 400 divided by 81. Great. So if I simplify this, let's say square root of 25 over 81, we can find square root of 25, we can find square root of 81, so that's very good. So this is log 10 15 over 8 minus log 10 square root of 25 is 5, square root of 81 is 9, plus log 10 400 over 81. Great. So look at this is log. They all have the same log, and there is minus and then there's plus. So I can group everything together and say log 10 15 divided by 8 divided by, so this is no more minus, it's not be divided by 5 over 9, and this will no longer be plus, this will be like times 400 all over 81. All right, so let me resolve everything. So this is log 10 15 over 8 because division is done to multiplication. times 9 over 5 times 2400 all over 81. Great. So let's divide now. 9 here 1, 9 here 9, 5 here 1, 5 here 3, 3 here 1, 3 here 3, right? 3 here 1, 3 here 800, 8 here 1, 8 here 100. So we'll be left with what? 1 times 1 times 100 and 1 times 1 times 1, which is like saying log 10 100. And we know log 10 100 can be written as log 10 10 squared, right? So I can bring this 2 down and say 2 log 10 10. I know that this is saying what? 1, right? Based on all things we've done before. So our final answer is 2 times 1, which is what? Which is 2. So by the time we resolve all of this very big thing, at the end of the day, the value is what? It's 2. Let's see if we're correct. Great. So the next question is saying evaluate log 6 base 10 plus log 45 base 10 minus log 27 base 10 without using the logarithm table. So to solve this question too, same thing, there's a plus, there's a minus, and they all have the same base. So I could just group everything and say log base 10 6 times 45 divided by 27, right? How can I be able to do? So 3 here 2, 3 here 9, 9 here 1, or 3 here 3, 3 here 15, 3 here 1, 3 here 5. Actually, those are 9, I mean, so this is log 10, 2 times 5 is 10, and this is like saying what? 1. So by the time we resolve all of this big thing, our value at the end of the day is just what? It's just 1. Let's see if we're correct. Great, so correct. And the last question says that we should evaluate log 6 minus log 3 all over log 8 minus log 4 divided by log 5 divided by log 0.2 without using table. So how can we solve this? When we told the base, we're not told the base. Whenever we're not given the base, we can assume that the base will be base 10. So let's see, let's solve this. So this thing, since we're assuming that the base is base 10, this top I can resolve it and say this is log 6 divided by 3 all over log what? 8 divided by 4 divided by log 5 over log 0.2 is something as saying 2 over 10, abi 2 over 10 or 1 over 5, right? So if I resolve this, is like saying log 6 divided by 3 is 2, log 8 divided by 4 is 2, so this is log 2. These two should cancel each other, divided by log 5 all over log 1 over 5. So basically this is 1, right? It's just this part I'm interested in. So this is log 5 all over log 1 divided by 5. This is basically what we have here. So I can resolve this further and say log 10 5 all over log 10 1 over 5, something I'm saying 5 raised to the power of minus 1, right? So if I say log 10 5 all over, I can bring this minus 1 down based on our laws of logarithm. So this will be minus 1 log 5 base 10, and I can cancel out this guy. So I'll be left with 1 divided by minus 1. So our final answer is what? Is minus 1, right? So this is how basically we're able to resolve this particular thing. You must, once again, you must see patterns, right? Pattern here is 1 over 5 is 5 raised to the power minus 1. Like resolving this one into its fraction, things like that, and you'll be fine. Let's see if our answer is actually correct. Minus 1, great. So that is basically the pointers or more examples on simplification in logarithm. In the next video, we'll be talking about substitution in logarithm. See you guys there.